So here we are in the land of triangles, which we know the best way to approach any problem is the triangle. So here we go. Let's try it out. So we're going to try to find the area of a triangle. And so this triangle right here um, is going to be kind of an example, right, that is going to help us find a formula. So we don't have any specific numbers here. We just have sort of, the broad strokes. So we know that the bottom of the triangle can be rotated, but in this case, way that that triangle's plopped down, the bottom one looks like base, right, because it's on the bottom. So we'll call that one our base. Perpendicular to that, so intersecting sort of at a 90-degree angle, you can see it labeled here with that little seat thing, if you will, that it creates kind of a square that tells you it's a 90-degree angle. From the vertex intersecting the base is how you find the height, right? So this little parachuter coming down from the highest point, the vertex, and intersecting the base at that perpendicularly, that 90-degree angle, height. So we can use that sort of height and base to notice that in order to find the area of a triangle, what you're going to do is you're going to multiply the base times the height, and then you're just going to take half of it. Well, why are you going to take just half of it? Well, we kind of explored this in the Edpuzzle video as well. But what is true, and we can prove why it's true. But right here, we're just going to kind of utilize knowing it's true. So if we pretend like those are perfectly straight lines, it can be really handy to use grid paper when you're doing this because you can see where the sort of, you can see it line up on your grid paper. You can make your triangle perfectly go onto the grid paper. In this case, we're going to just be a little bit flexible, but here we go. So we've put this sort of rectangular shape around our triangle where this vertex and this vertex and this vertex, right? They are each touching the rectangle. And it tells us, right, that the height goes still from the base up to the top, right? So this height is the same anywhere you go along from the top to the bottom. And the length stops specifically at the end points here. Okay, that is going to be true of the rectangle around this shape as well. The rectangle is just going to fill in sort of other parts. So um, if we wanted to find the area of this rectangle, we would simply say we're going to take this length and we're going to multiply it by this width. We get the rectangle. Well, the triangle is exactly half. If we took this red portion of this triangle and let's just say that this rectangle here and this rectangle here, let's call them two rectangles for now. Okay. And so from the vertex, we've gone down, we've created a red rectangle and a green rectangle, and we are going to take exactly, we'll just shade in half of each. So we're leaving the original triangle white. We're going to pretend like all this is perfectly shaded in. So in order to find the area of the rectangle, we do the width times the length, right? Or we could think of it like the base times the height. So if we do that, right, well, we don't want the area of this whole red rectangle. We just want half of it. And by chopping it in half from corner to corner, we have literally split it in half. So we know that the red is too much by exactly half. Similarly is true over here for the green rectangle. We'll take the width, multiply it by the length, and then we'll take only half of it because we've cut it from corner to corner. We don't want any of this green part. We just want the white part. So we could then add those two halves of the green rectangle and the red rectangle together, right? And that will get us the area of the triangle. We also could just say we're going to take the area of the rectangle base times height, and then in the end, cut it in half. So let's try it out with some real numbers. So over here, we have a triangle. We can see that we want to find the area by multiplying the 9, the base, times the height, 4, and then cut that in half. Well, let's do it. So we could then say, all right, we'll take half of what's 9 times 4, 36. Well, then we could say, all right, the area is half of 36. So it's 18 feet squared, 2 dimensions, height